Hi guys, so in this video I'm going to be going over one of the most important parts of math that is going to be used in so many different areas. It's known as the Pythagorean Theorem. So the Pythagorean Theorem basically links two sides of a right-angled triangle to its third, the hypotenuse. So let's just go over what this triangle may look like. So for example, let's say we have this triangle over here. Oops, let's just ignore the square for now. Okay, and this has a right angle at 90 degrees at that point. And basically, let's say we have this side length is 5 and this is 12. This is definitely not to scale, but I'm just putting numbers in here. Well, what if you want to just find the length of this side over here? The hypotenuse, which joins the two legs by which an angle of 90 degrees connects. Well, we would have to use the Pythagorean theorem. So today we're going to be looking at how we can derive such a theorem so that we're able to find the length of that third side. Okay, so in this, let's just take our attention to this square over here. So in the square, we have 4 different triangles. Let me just shade them in here. We have 4 triangles over here, and in the center, they've made a square with angles 90 degrees. Okay, so I've just roughly highlighted the 4 triangles. So they are all equal. Let's just say they're all equal. So let's give this side length A, this side length A, and let's just say this other side length is B. So as we can basically see, these are all 4 congruent triangles with side lengths A as the longer one and B as the shorter one. And let's just call that the longer side length that makes up the center triangle C. So we can see that we've designated the hypotenuse, the variable C, and we're going to try and find that out now. So we're going to use A and B to link it to C with a general proof. So what we should first think about is, what is the area of this large square, the whole thing that contains the 4 congruent triangles and the square in the middle that's looking a bit like a diamond right now. Well, we can see that this side length over here, let me do it in a different color. This side length over here has length A plus B, and this side length over here has length A plus B. So obviously it's a square. So that means, let's just move this down. The area of the square is A plus B squared. Now, how else can we find the area of the square? Well, what we could do is just add up all the different parts that make up this square. So we could add up the areas of the 4 triangles and the square together, which is equal to, so the area of a triangle is half base times height. So in this case, it's half A times B. And we're going to multiply this by 4 since there are 4 of the same triangles over here. And then we have in the center, we have the square, which has area C squared. Now, if we simplify this down, we get A squared plus B squared plus 2AB is equal to, and then 4 times a half is 2, 2 times AB is 2AB plus C squared. And as we can see over here, the 2AB parts cancel out, and we're left with A squared plus B squared is equal to C squared. And this is the big equation that so many mathematicians today use in all sorts of problems. It's an essential thing that you'll need to know for your exam. So now that we have the information that A squared plus B squared equals C squared, how do we use it? Well, let's take a look at this triangle over here again. So let us say that A is the longer side, let's just say it's 12, and B is the shorter side, which is 5. If we put this in the equation, that means C squared, which we're going to name our hypotenuse, is equal to 12 squared plus 5 squared, which is equal to 144 plus 25, which is equal to 169. Now, if we square root C squared, we get C is equal to plus or minus 13. But obviously, we know that this can only be positive because length can't be negative. So C is equal to 13 units. And that's how we can connect the different legs together. I'll put up another problem. I'll go through another problem just now to show how we can apply it to a variety of situations, because this is a very simple equation, a simple part where it's been placed. But if you want even more problems as well, you can always check out the geometry section, the trigonometry section of this channel, which contains a lot more information about that. All right, let's take a look at this practice problem over here. So shown below is a cuboid. AB is equal to 8 cm, BC equals 3 cm, and CG equals 4 cm. And they labeled that for us, so that's not very difficult to visualize. Find the length AG. So length AG, let's just write that down here, is this line over here. And as we can see, it goes in between the cube because G is actually on the further side of the cube. So what we need to do is use Pythagorean Theorem twice. What we have is GC, but we need to also find AC, because if we GC and AC are part of the triangle where AG is the hypotenuse. So if we draw a line to AC, we can now see that we have a right-angled triangle working with. So what we need to do is let's say AG we denote with the variable x, and AC, which we don't know yet, we can find now. So we know that AC squared, according to Pythagorean theorem, is 3 squared plus 8 squared, which is equal to 9 plus 64, which is equal to 73. That must mean AC is equal to root 73. Knowing this, let's just label that right now. Knowing this, now we can use Pythagoras to find x. So we know that according to Pythagoras, since x is the hypotenuse, x squared is equal to 4 squared plus root 73 squared, which is equal to 16 plus 73, which is equal to 89. So x is equal to root 89 cm, and that's equal to approximately, let me just put that in a calculator, that's equal to approximately 9.434 cm. And that's our answer. Important thing to note that when we're looking at Pythagoras, the hypotenuse is always the C. But it doesn't matter how we order A and B, as long as they're the side lengths of the triangle. We can also rearrange Pythagorean to find other values. So let's say we had C is 5, B is 4, but we don't know what this length over here is. Let's call that A. So we could just rearrange Pythagorean to get 5 squared minus 4 squared is equal to A squared. As if we look at the original equation, A squared plus B squared equals C squared, we can rearrange that to make A squared is equal to C squared minus B squared. And through this method, we get 25 minus 16 equals A squared, and A equals 3, as it's A squared equals 9. So that's just how you would use the Pythagorean theorem. It's not very difficult to use, but it's so helpful when you do know how to use it. Anyway, that's enough for this video. Thanks so much for watching, and keep an eye out for any geometry or trigonometry questions, as they may very well need Pythagoras. It's just a very good algebra basic to know about. Bye for now.